Okay, another black box testing is known as boundary value analysis. Okay, so it is a test case design technique that complements equivalence partitioning. Right, so what happened for this boundary value analysis? The testing happened between the extreme ends or boundaries between partitions of the input values. So it is looking at the input conditions and checking the extreme ends, yeah, or the boundaries or the limit. So boundary value analysis testing technique is used to identify errors at the boundaries rather than finding those that exist in the center of the input domain. So it is checking actually at the extreme ends, okay, extreme ends of the input domain, and to observe, yeah, the output. Okay, say for example, if let's say the input condition accepts value between the range between A and B, for example, right? So by using this boundary value analysis testing method, what will happen is that we can design the test cases in such a way that we will test the input value, yeah, by considering the minimum value, right, or just above the minimum. Okay, just above the minimum. Let's say minimum value is 20, so just above the minimum is 21. All right, and then a nominal value somewhere in between, and then just below the maximum and above the maximum. Okay, so we can test in such a way that we can see whether the input is actually according to the limit or not, the limit defined. Okay. Okay, another kind of black box testing is known as comparison testing. So comparison testing is used only in situations in which the reliability of software is absolutely critical. Absolutely critical, yeah, and we are talking about human-rated systems. Yeah, human-rated systems are systems that accommodate to the human needs, like for example, the system in the hospital, yeah, the system that you use for example, for surgery purposes, kind of like that, or any other real-time system that is critical, right? So under this comparison testing, what happened is that we need to allocate separate software engineering teams, yeah, that will develop independent versions of an application using the same specifications. All right, so it is expected that we need to test it so that we can ensure, you know, the reliability of the software. So we have to kind of like duplicate it. So each of the version can be tested with the same test data, and to ensure that all provided identical output. Yeah, so that's the reason why they develop another version of the test. Yeah, so that to ensure that they receive the same output. So all versions are executed in parallel. Yeah, with real-time comparison of results to ensure consistency. Uh, okay, also orthogonal array testing. This is another black box testing. Okay, so this is used when the number of input parameters is small but too large to allow for exhaustive testing of every possible input to the systems. And the values that each of the parameters may take are clearly bounded. So for this orthogonal array testing, it enables us to design test cases that provide maximum test coverage with a reasonable number of test cases. Okay, so there's one example here. To illustrate the orthogonal array testing, all right, if there is one input one at a time, yeah, we can actually, of course, using the conventional method, yeah, we can accept the input and design a test case in such a way. But by using orthogonal array, we can minimize the number of test cases. Okay, one example to illustrate this one. Okay, if for example, if let's say in a particular module or function, let's say we have we require a set of parameters. Okay, let's say we define 4 parameters, and each of the parameters, yeah, let's say each can have 3 values. Yeah, each can have 3 values. So the possible number of tests, yeah, if we are using conventional method, is 4 power of 3, which is 81. So we need to have 81 test cases, yeah, in order to ensure that we go through each individual values, because each of the parameters have 3 distinct values. For example, 1, 2, and 3. right? But by using orthogonal array testing, it boils down only to 9 test cases. So it is orthogonal, yeah, orthogonal in the sense that we are catering all possible pairwise combinations between the parameter. Right, so the testing is not only concerned on one particular input parameter, but it is it's a kind of like you are combining, yeah, more than one parameter, so test at once. That's why you can reduce the number of test cases. Okay, so basically we can reduce the effort, yeah, or the time taken to actually perform the testing. Okay, model-based testing. This is another kind of also black box testing. So for model-based testing, it is concerned about testing the behavior, yeah, behavior of the systems. So there are a number of steps, yeah, to execute this model-based testing. The first one is that we need to analyze the existing behavioral model. So if you can recall, we developed this behavioral model during the requirements analysis, right? When you develop the state diagram, all right? So you need to have that one first. So we analyze the existing behavioral model for the software. So we rely on the UML state diagram, mainly UML state diagram. Or if we don't have, then we need to create one. Yeah, if this kind of testing is needed. Alright, so behavioral model indicates how software will respond to external events or stimuli. So then, based on that behavioral model, we need to traverse the model, traverse the behavioral model and specify the inputs that will force the software to make the transition from state to state. So the inputs will trigger the events that will cause the transitions to occur. Alright, so from that point we can see how the traversing occur, and then we shall review the behavioral model and note the expected outputs as the software makes the transition from state to state. So we need to, when we review it, then we observe, we observe what is the expected outputs, and then we execute the test cases, and then we should compare the results from the test cases, the results from the actual and the expected results, from the one that we have observed, and take corrective actions if needed. Okay, now talking about software testing, there is also what we call as software testing patterns, right? So software testing patterns are described in much the same way as the design patterns. So if you recall last time we learned about design patterns, when there is one common solution, commonly used solutions that is available, so one can actually define patterns. So testing patterns describe common testing problems and solutions that can assist you in dealing with them, right? So for example, let's say the pattern name is scenario testing. Okay, this is just one example. And for this scenario testing, once unit and integration tests have been conducted, there is a need to determine whether the software will perform in a manner that satisfies users. The scenario testing pattern describes a technique for exercising the software from the user's point of view. So a failure at this level indicates that software has failed to meet a user visible requirement. Okay, so this is one kind of pattern called scenario testing pattern. Of course, there are many other patterns available for software testing. Okay, and then this is what they call as exhaustive testing. Exhaustive testing is a kind of testing where it is actually indicated like impossible. It's impossible to design the test cases for exhaustive testing, because if you, for example, look at this control structure, this flow chart. If let's say you have nested loops, there's a nested loops, and then in each nested loop there are some more further if else conditions. So if this kind of situation, for example, one loop takes 20 times, so according to this design, there are around 10 power of 14 possible paths. So if we were to consider this kind of conventional testing, if you were to execute one test and it takes like 1 millisecond per test. So if you were to have this much pass, yeah, independent pass, we're talking about independent pass, so it would take around 3,170 years to test this program. So in those days, this kind of testing, of course, is impossible. But nowadays, perhaps if it requires such an exhaustive testing, maybe not in all situations, but in certain um, critical system, probably if it's required, maybe, well, an advanced automated testing technique is needed. Not a manual one, definitely, because it's impossible to do it manually. But an advanced automated software testing perhaps can cater for it. Of course, it requires higher processing power to do that. Okay, and then well, there is also what we call as selective testing. So selective testing here is when we perform the testing, but we choose certain only selected paths, for example. So that's why we call it a selective testing. We don't test for the whole path, right? And this is very much relates to the regression, regression testing. So for if let's say we are in a situation where potentially to have kind of like exhaustive testing like this one, so one of the ways to minimize the testing effort is by actually running the selective testing, where we perhaps consider only critical paths, the critical paths that we need to check. So and those are the simpler paths, easy paths, maybe we don't put much consideration there. But for selective testing, we can put focus on the certain selected paths, so that we can only put effort and focus on that critical critical module, for example. Okay, I think that is all for this topic.